So now we have seen a couple examples of Green's theorem, how it applies. It's very fun because you relate a line integral with something that you have learned before the midterm double integral. But be careful when you apply Green's theorem. You need to check the hypothesis carefully. Now we discuss an example that Green's theorem does not apply directly. Okay? This is an example that we discussed actually last week. So if you remember the focus example, this example 8, okay? And then you have a vector field, okay, that look like this. So for simplicity, I'm going to take alpha to be 1. So if I take alpha to be 1, then this is the vector field. So part A, evaluate Qx and Py, right, and then subtract them, okay? So what is P? P is the component, the I component, okay, of your vector field. So it's minus y, x squared plus y squared. And then what is Q? Q is the jth component. So it's x over x squared plus y squared. Okay? So what is Qx? Careful computation. If you use quotient rule, you get 1 times x squared plus y squared minus x times 2x. Over x squared plus y squared squared. So you get y squared minus x squared and x squared plus y squared squared. Okay? Py. Okay? Py would be minus x squared plus y squared. Minus y, so you get plus y and differentiate 2y. And the x squared plus y squared squared. And then so at the end you get the same thing, y squared minus x squared over x squared plus y squared whole square. So therefore Qx minus Py is 0. Okay? And then part B. Evaluate, let's see, be the circular path center of the origin or radius r. So C in this case is just a circle. Circular path or radius r, okay, anti-clockwise, and then evaluate the line integral of this, okay? You may think of doing like this, okay? This is how not to do it. So how not to do it is I want to evaluate this line, typo, C, F, D, R. Let me apply Green's theorem. By Green's theorem, this is the double integral over the region D bounded by the curve Qx minus Py dA. But then by part A, I know that this is 0. Integrating still, of course, this is 0. Okay? And then turns out this is wrong. Okay, wrong. But then what's wrong? What's wrong? Firstly, what's the correct answer? The correct answer we actually calculated last week. So, from last week, if you do direct computation, by direct computation, see example 8 from week line, okay? If you look at what we did last week, at the end the answer is 2 pi alpha. In this case, alpha is 1. Therefore, you get 2 pi, which is not 0. So, does it contradict with Green's theorem? Green's theorem does not apply here. So what's wrong? Okay, what's wrong? So of course, this does not contradict with Green's theorem. Green's theorem is true. But then, okay, so this does not contradict with Green's theorem, okay? But why? Because if you look at the hypothesis of Green's theorem, okay? If you look at this, what do we require? We require the vector field to be continuously differentiable on D. So P and Q, the component function, need to be continuously differentiable. So if you look at this, so because, okay, Green's theorem require P and Q, the component function, to be C1 on the region, okay? On the region D. So what is the region? D is the region. So D is D, okay? But look at my function. P and Q has a denominator. And then, clearly, not even talking about differentiability, they are not even continuous there at the origin, because at the origin it will explode. So P and Q are not continuous at the origin, okay? So, well, an origin is a point inside the disk, so that's why you cannot apply Green's theorem, okay? So however, in this case, what is D? D is the disk, okay? But this disk contains the origin. And at which P and Q are not continuous. Are not continuous, so hopeless to be C1, okay? Therefore, you cannot apply Green's theorem here. But is that the end of the story? So, spoiler alert. This will be fixed by what we call generalized Green's theorem that we'll learn at the end of this week, okay? So this is not the end of the story, but I just want to warn you that when you apply Green's theorem, be careful. Especially in the case when P and Q are not continuous in some point, then you need to make sure that your region does not contain those points of discontinuity. For example, in this case, P and Q are not continuous at the origin, but the disk contain the origin, therefore Green's theorem cannot be applied here.